Good evening. Welcome to the University of Charleston. It's great to see you here on a wonderful spring day. It's coming, folks. We have a guest from Tucson, Arizona, so he promised to bring it. So, I'm Ed Welch, president of the University of Charleston, and it's great to welcome you to the University of Charleston Speakers Series for what promises to be an interesting translation. It should be entertaining and informative conversation tonight. University of Charleston is very fortunate to have a fantastic partner for the Speakers Series, and that partner is the Dow Chemical Company. Since 2001, the Speakers Series has been sponsored by Dow Chemical Foundation. We are extraordinarily grateful for their support of the university and of the community. And representing Dow here tonight are Jonathan Reese, who is just moving here from Louisville, Jose Carrasco, Anna Marino, and Chris Sizemore. So if they would stand so we can see you and just thank you. Wherever. There you go. Thanks so much. Also want to thank Monsignor Sadie, who is here. Where isn't he in Charleston? But he's here tonight. Sorry. I told him we were having a conversation. I had this wild idea sometime about having a conversation on this theme, and he said, "Oh, I know somebody who can do that." And so he provided the connection that resulted in our having this speaker. So thanks to the Monsignor for helping out. I do invite you at this time to do what you're supposed to do in these settings, and that is turn off anything that makes noise, like alarms and cell phones and those good things. You're invited to write questions you might want me to ask the speaker. We're going to have a brief video. He and I will have some conversation, and then I will ask questions that you pose. So write them out, pass them to the aisles, and we'll have ushers pick up questions. They will then give me samples of the things that most of you are interested in. If you've written a question that we do not ask, I apologize, but we will get to as many of them as we can. Our guest tonight is Father Chris Corbally. He is a Jesuit priest. They seem to be in the news these days. He is the president of the National Committee for Astronomy in the Vatican. He served as vice director for the Vatican Observatory Research Group in Tucson, Arizona for many years, and as president of the Institute on Religion in an Age of Science. He is well experienced and a fantastic person to have talk about what we want to talk about tonight. Father Corbally was born near London and entered the Society of Jesus immediately after high school. He has a philosophy degree, a physics degree, an astronomy degree, a theology degree, in addition to his PhD in astronomy from the University of Toronto. He is still an active researcher using the telescope at the Vatican Observatory in Tucson, Arizona, to study stars and star systems. So if you will, welcome Father Corbally to Charleston. Glad to have you in West Virginia. Thank you very much. And I'll let you introduce the video, and if some of you have trouble seeing, we'll try to duck out of the way, and if standing helps you for that brief time, that's helpful. The video's about 8 minutes or so.
And if we could have those lights down, if that's possible. Oh, okay.
It's there. It's pretty bright.
That's great. Lovely. Thanks. And this is, as it says there, the Hubble Deep Field. Give you an orientation to the universe.
Astronomers in 1996 attempted to do something extraordinary. They pointed the Hubble Space Telescope into a part of the sky that seemed utterly empty, a patch devoid of any planets, stars, and galaxies. This area was close to the Big Dipper, a very familiar constellation, and the patch of sky was no bigger than a grain of sand held out at arm's length. This was a somewhat risky move by the scientists. After all, observing time on this telescope is in very high demand, and some questioned whether it would be wasted trying to look at nothing. There was a real risk that the images returned would be as black as the space at which it was being pointed. Nevertheless, they opened the telescope and slowly, over the course of 10 full days, photons that had been traveling for over 13 billion years finally ended their journey on the detector of humanity's most powerful telescope. Their feeble signals collected almost one by one. When the telescope was finally closed and the images were processed, the light from over 3,000 galaxies had covered the detector, producing one of the most profound and humbling images in all of human history. Every single spot, smear, and dot was an entire galaxy, and each one containing hundreds of billions of stars. Later, in 2004, they did it again, this time pointing the telescope towards an area near the constellation Orion. They opened the shutter for over 11 days and 400 complete orbits around the Earth. Using detectors with increased sensitivity and filters that allowed more light through than ever before, over 10,000 galaxies appeared in what became known as the Ultra Deep Field, an image that represented the farthest we've ever seen into the universe. The photons from these galaxies left when the universe was only 500 million years old, and 13 billion years later, they end their long journey as a small blip on a telescope CCD. These galaxies, while standing absolutely still, are racing away from us, in some cases, faster than the speed of light. The space-time between us and everything else grows larger by the minute, pushing the galaxies in this image to a distance of over 47 billion light years. And because of universal expansion, the farther something is away from us, the more its light is shifted toward the red, and the faster it appears to be moving. Edwin Hubble himself discovered this by measuring the redshift of many galaxies, and it's a measure of not only speed, but distance as well. Recently, Hubble scientists put the icing on the cake. Using the measured redshifts of all the galaxies inside the image, they made a 3D model of the ultra-deep field. This is how it looks when we apply the distances of the galaxies in the most important image ever taken. There are over 100 billion galaxies in the universe. Simply saying that number doesn't really mean much to us because it doesn't provide any context. Our brains have no way to accurately put that in any meaningful perspective. When we look at this image, however, and think about the context of how it was made, and really understand what it means, we instantly gain the perspective and cannot help but be forever changed by it. We pointed the most powerful telescope ever built by human beings at absolutely nothing, for no other reason than because we were curious, and discovered that we occupy a very tiny place in the heavens.
And now, just to make sure that that didn't make you go completely to sleep, we will have a 2-minute little showing to give you an idea of the Vatican's telescope up on a mountain in Arizona, which also shows its 2 companion telescopes as well. And we'll have the sound, the audio, hopefully for this video. And if you feel like dancing, then do. It was shown first to the program called Around the World in 80 Telescopes, and indeed went round, visited 80 telescopes in 24 hours by a group in the Netherlands. Arizona was near the end of the 24 hours, with the West Coast, California coming next, and then finally Hawaii. So the pretty tired, crew in the Netherlands by this time. They said they really woke up when they showed this one as the introduction to the 15 minutes worth on the Vatican Observatory. It was also shown at an exhibit in the Vatican Museum during that same year. Unfortunately, they didn't have the sound. Let's see if we can have both. Thank you, Scott. Thank you very much, Scott, and thank you, David. I think we can have the lights up.
You've done it already. I mean, you're out there talking about millions and millions of galaxies, and how many people do you think really can fathom the immensity of the world, the cosmos, the universe?
Probably none.
Okay, but your challenge is to try to help us to understand that a little bit. Would you mind starting with some definitions for pedestrians like myself who don't understand everything about, planet, star, cosmos, world, universe, galaxy?
Mm-hmm. We can start at home. We're on a planet, the Earth. There are 8 of these now going around our sun, which is a typical star. It's good to live next to a typical star because it lasts quite a long time. It's not big and bright and burns up quickly, or rather small and dim and rather hard to sort of warm yourself by. So that's our sun, a normal star. In our galaxy, which is a collection of some 100 billion stars, plus gas and dust as well, and something we call dark matter and don't quite know about. Anything dark, anything we don't know about in astronomy, we call dark. It's so simple that way. Or black, like, that idea. So our galaxy is one of about the same number of galaxies in our universe as there are stars in our own galaxy. So that's about 100 billion galaxies in our universe. And if you're wondering quite, how many that is, somebody was telling me recently, each of you has got 15 galaxies. Okay? And everyone, who's lived on the Earth has got 15 galaxies each, so that's about it. I think that should be enough. Yeah, the universe is vast in number and vast in extent, because the age of the universe was actually, since last week, has become a little bit older. Isn't that grand? In that last week, it became 1/10 of a billion years older, or 100 million years older. So we now put the age of the universe at 13.8 billion years. Quite a long time. Age of our galaxy, about 10 billion years. The age of our sun, about half that, about 5 billion years. And our Earth and solar system came in formation not too long after the formation of the sun, maybe something like 4.6 billion years ago. Big numbers.
Big numbers, yeah. Is there one universe, or are there multiple universes?
Don't know.
You're the expert.
Not even the experts will know. Though you always ask a theoretician and they'll always know. That's just wonderful. I say that off the cuff because in 1987, so a while ago, I know for some of you, a star exploded, went supernova, dramatic. It was first spotted down in the southern hemisphere by someone whom I know quite well in Shelton. And when they kind of went back to old records of that area of the sky and could trace and see what kind of a star it was that had gone supernova, it never should have done. It was a blue star, and everyone knew that yellow and red stars would go supernova, but not a blue star. It only took a week, and the theoreticians had worked out exactly why a blue star would go supernova. So this is astronomy. It is, I joke a bit, but it is dependent on observations, and because of that, we find observations surprise us, and so our theory then catches up to understand that. So it is a wonderful game, as it were, between observation and theory that gets played in astronomy. Where are we?
Right here in Charleston. That part I know. Beyond that, it gets a little tough. One of the factoids I did read is that if you traveled at the speed of light for 100,000 years, that you could move from one edge of the universe to the other.
No.
No.
One edge of our galaxy to the
not
other.
The universe.
Yeah. Mm-hmm.
Okay.
Yeah.
Bigger still.
Bigger still.
Okay.
And I believe if you travel for some 70 billion years at the moment, 70, you could get from one edge of the universe to the other. Billion, yeah. But that's growing, so by the time you did that, it would have gone out further, faster than the speed of light on both sides, so you'd still be traveling. I don't know.
And in terms of personal experience, we probably will not have the evidence to find out whether that fact is correct or not, but I accept what you're saying.
So far.
It is, it is just magnificent to try to comprehend what the world is all about.
And so that's the idea of that little view of, from the Hubble telescope, looking, I don't know whether you caught it at the beginning, looking at an area the size of a grain of sand held at your arm's length. Anyone who, without bumping their neighbor, can like to hold their hand out and just think of a grain of sand at that distance. That's what it was looking at, and all those galaxies saw there, right to the the edge at least of the currently observable universe, about 500 million years since the beginning of the universe. Incredible.
There's an interesting website, or at least I found it interesting, called Scale of Universe, scaleofuniverse.com, which in one site, on the one hand, starts out with human beings and goes down to infinite particles, and on the other hand, expands to take in the kinds of things we're talking about today. So if you want to challenge your mind and get some perspective about where human beings are in the world, it's an interesting one to look at.
But one of the interesting perspectives of that is that our human scale is right in the middle, between the very large, to the end of the universe, and the very tiny in atoms and within atoms. So it's amazing how we're midway. Congratulations.
We worked hard to get here. I'll let others of you, if you want to ask questions about astronomy and the immensity of space itself. Let me make a little transition and say that Christianity in general and the Roman Catholic Church in particular have not always been perceived to be friendly to science. Why is that so?
What we're thinking about is the presumably the 16th, 17th century, so the 1500s to the 1600s, which is the transition to modern science. And one name that pops into your mind would be Galileo. I hope Giordano Bruno doesn't pop into your mind too much. Dear Giordano, who was burnt at the stake in the year 1600, was burnt not so much for his belief in civilizations beyond our own, as I think for his philosophy and his theology. And when you start denying the divinity of Christ and things, at that time, do expect things to get a little hot for you. But at least Galileo got away with house arrest, so he was confined to his own small but very pleasant villa that's just outside Florence at Arcetri. And, what was the problem of that time? It was transition. It's sometimes very hard to get used to new ideas, but obviously that's why you're all associated, maybe studying or come to a university. It's new ideas that you are trying to understand. But in certain circumstances, especially when you are getting attacked, then new ideas are hard to assimilate. And the Catholic Church in that time was getting attacked, if you'll forgive me, by Protestantism. And so that's why when you're attacked, you sort of withdraw and sort of set up the barricades. So this new science, this new perspective on the universe that Galileo was bringing, that our Earth was not at the center, but our sun was. Well, as we know, our sun was at the center of the solar system, not the universe, but anyway, that had to develop. But so anyway, bringing the center of things away from the Earth was attacking the understanding people had then of the Bible and the interpretation of the Bible that had come through the tradition of the church, from the church fathers, and all the understanding. So it was attacking traditional understanding of the interpretation of the Bible. That was why there was a problem with this new science. And did this new way of understanding and have knowledge have more weight than the old, that was based on all the tradition that had gone before? So that was the question, and that was the problem. I think what we need to do is sort of get back into the mentality of that people, and not to be too quick to condemn. Oh, you all condemned Galileo, that was terrible. Yes, it was, and mistakes were made, but they were understandable mistakes that we could well make ourselves. I think that's always kind of a perspective to keep.
So you have an institution which has been perceived to be very traditional, and so you're talking about when that tradition ran into new ideas.
Mm-hmm.
And now you have an institution, the Catholic Church, that has observatories. Why does the Vatican have observatories? Why is it now so supportive, apparently, of science?
Well, one fact there, and let's base things on fact, is that, of course, the Vatican Observatory tradition goes back before that young upstart Galileo came on the scene and thought he knew about everything. So some dates then. 1592 it was, and Galileo was sort of first made the telescope and turned it on the heavens in 1609, or the end of 1608, so beginning 1609. And so some years before that, a group of people approached Pope Gregory XIII to point out that the calendar that they were using since the time of Julius Caesar, so a good 16 centuries, was getting out of step with the seasons. So when it was saying, spring was actually coming back into winter. And why it affected the church, of course, is the feast for us that's coming up on Sunday of Easter. And Easter in the northern hemisphere is associated with spring and with new life and the resurrection of the Lord. And to have it going into a winter festival, so rather like today here in Charleston, doesn't give at all the right idea about Easter, does it? So that's why a group of people advised Pope Gregory on how to reform the calendar, and that group actually included a Jesuit, Christopher Clavius. And so we are operating now under the Gregorian calendar rather than the Julian. And so, the church's, Catholic Church's involvement with astronomy has gone back a long way.
Do you believe in evolution?
I certainly believe in change.
The theory of evolution?
Yes. And you'll even find Pope John Paul II in an address to the Pontifical Academy of Sciences, which is the scientific society that the Catholic Church runs, that his address there in the 90s was basically accepting that the theory that evolution was no longer a hypothesis. It had become a theory. Use the word theory with, carefully. Oh, that's just a theory. No, that's, a popular way of using that word. For science, a theory is something that, has been an idea, and then an idea that through repeated observations and interaction with the physical universe has been tested, and it's darn well the best thing, way we have of understanding our physical universe. So to go from a hypothesis to theory for evolution was a really big step. The church, we note, was rather cautious about it. After all, Darwin was talking about this quite a while beforehand. But okay, fair enough, caution's okay. But the church accepts evolution as the gradual, the progressive change in the universe as the way things have come to be and how we are sitting here now.
The most recent Gallup poll I could find said that, on the subject, said that 46% of the American people reject totally the idea, concept, theory of evolution, and believe that God created human beings in their current form, as we know them. My guess is a good percentage of those 46% would expect you as a person of faith to be agreeing with them. Now, when you stand and think as a Christian, a Catholic, and as a scientist about that phenomenon of what many people believe versus what seems to be a theory that we cannot in any way, shape, or form disprove, how do you put together, how do you fathom that part of our existence?
Oh, quite simply. I go back to Galileo. Because Galileo was quoting a bishop of his time when he said that he looks to the Bible to find out how to go to heaven, not how the heavens go. Do thank Galileo and his source too. I forget for the moment the bishop's name, but it'll be there and found. Exactly. It's a wonderful way to put it and to realize that if I want to try and find out how things go, then I look to science. I look to textbooks to find that out. I look to the best theories in the scientific way, manner of speaking of these, what's going on. So for the, how the universe developed from the beginning through to the present time, so the path of evolution, I look to science in all its various aspects. We've obviously, my expertise is in the astronomy side of things, and then we have to form planets, so we go into sort of geology, we go into biology, we go into anthropology, we go into sociology, we may even go into politics. But, so this is
not in the Vatican.
There's fortunately no politics in the Vatican.
Yeah, right. Okay, good.
There's a little story on that we may come to. 3 Jesuits who were brought into the Vatican as a team in the late 1950s. We called them the 3 Musketeers. They used to discuss things rather as we're doing this evening, over a glass of wine at the end of the day. And then when it was time to retire, they would go onto the balcony up there and look up, and one of them would exclaim, "Oh, thank heavens, there's not a shred of politics in the Roman Catholic Church." Somehow they'd all sleep very happily afterwards. How do things develop? So obviously, what I've said is, Galileo's understanding that we look to science to see how things go. What we look to the Bible, how to go to heaven, yes. What we look to the Bible for is what is the relationship between the Creator and this wonderful story of evolution that science gives us. So we're looking to the Bible for a relationship of Creator to creation. You're not going to find that in science because that's not the object of science. So, a discipline specifies a certain object that it's interested in and a methodology of how to tackle the questions that arise as you look at an object with that aspect. So theology, or our faith, looks at our universe, but looks at what is the relation of the Creator to this universe. So it's not a scientific question. And the problem is when you confuse it and when you look into the Bible for scientific answers, they're not there. Is the Bible true? Of course it is. It's wholly true in what it says about the relationship of God to creation. That will not change. If you look in the astronomy textbooks, the science textbooks, you can throw away the ones of a few years ago, because science has superseded. Science has learned more, and that's the nature of science, to keep adding, to keep changing. But the nature of the Bible is obviously a truth that is eternal.
I heard an insightful minister articulate the same points by saying that the Bible is a book of faith, not a book of science. And so that person went on to say we shouldn't be shocked if we were to find scientific or historical inaccuracy, but what we find in the Bible is truth about God and the relationship between God and his creatures, which seems to me to be a way to find, I guess, a clear definition or understanding of two different disciplines that overlap. A good friend of yours and another scientist and Vaticanite, Guy Consolmagno, whom we've talked about, you and I have talked about, says that science cannot be used to prove God because that would put science ahead of God. Is that something that you would find yourself in agreement with?
Yes, I'd certainly find myself in agreement.
He goes on, just to give you a little context,
please, yes,
I guess.
Yes,
I mean, he goes on.
I'm worrying about the ahead.
Yeah.
Yeah.
I'm not trying to trap you on this question. I'm saving that.
And we can blame my good friend and colleague Guy anyway, so that's fine. He's not here.
Yeah.
He's got broad shoulders too.
But he talks about the God gaps, his word.
God
gaps theology, that for many people we have said we don't understand this, and therefore God did it. We don't understand creation, God created it. And then science comes along and develops or gives us an explanation, and then we say, well, we don't need God to explain that. We now know that in some other ways. So that was the context in which he was talking about the relationship between science and God.
And that's absolutely right. So yes, when you don't know, you sort of kind of put God in, and God becomes God of the gaps. Oh, in a way, I as Guy as well, and other people have thought about it, find that actually so demeaning of God. God is bigger than that, of kind of being the solution to things that we can't understand in the physics of things. God is far bigger than that. So it's a pity when we do that, just haul in God as the easy explanation. No, God is the reason why we ask that question. And God is the reason why we have, hopefully science to answer that question. While, of course, realizing science is not going to answer all the questions, because the methodology of science is not designed for that. It's very, very powerful. Please use it. I hope you love it, and things finding out, like about the universe we saw in those pictures there. But God's not going to be the answer to, science is not going to be the answer to everything.
The Big Bang, is that a scientific explanation for what we know as the universe?
It is. It's our best one at the moment. The phrase "the Big Bang" comes from a wonderful British astronomer, scientist, Fred Hoyle. Because Fred and his colleagues had an alternative theory that was called the steady state universe. So he poked fun at this idea that everything started in a tense concentration and exploded, from there. So he called it the Big Bang. Unfortunately, as it were, the egg went into Fred Hoyle's face, and everyone loved the phrase "and Big Bang we've got." So it is our best explanation of how
And
things.
it says unbelievably that the universe began in some particle, maybe the size of an atom, that exploded, and we see what you showed us on those the introductory video.
Mm-hmm.
That's mind-boggling.
It is mind-boggling. In our Vatican Observatory, one of our members is Father and Dr. Bill Steger, and he's a cosmologist, and he tries to wrap his mind around these things, as well as possibilities, of other universes, so the multiverse theory with his colleagues. But then I listened to Bill explaining, and kind of my mind wanders. No, it's tough stuff. Mm-hmm. But obviously, it's what we can do, and it's the best we can do in science currently. What science will never tell us is why the Big Bang rather than not. It'll tell us how, how things then happened, but never the why, the ultimate cause of things. Yeah.
How do you pull together the Big Bang with the story of creation? That 6 days was a time frame for the creation of the world that we know it. And the people who were writing those scriptures did not have the awareness of what we found out from Hubble and Voyager.
Yeah. So the people writing those scriptures were using the best stories that they had at the time. There's a story number 1 in the first chapter of Genesis, and the story number 2 in the second chapter of Genesis, just to realize there are a couple of stories, at least a couple circulating there. Those are the ones that were written down. Our story today is the one that we have through science and that evolution. But let's say that back to the first chapter of Genesis and the days. What I suppose one can see a parallel with current science is to say that things didn't or just happened. They didn't just appear. There wasn't, as it were, God waving a magic wand and everything was as we know it now. There was a progression of things, a fascinating progression of things. There were, the universe explored, and so went up alleys that led nowhere, and found others that were very fruitful, and went on and produced other things. So a lot of exploration going on. Person who's just retired recently from the Vatican Observatory, but continues very much in teaching a chair. He's at Syracuse at Lemoyne College, Father George Coyne. Picked up very much on an idea not his own, but one that he very well expresses, is how God gave the universe freedom to explore. And that's the wondrous thing. It's, as it were, the scientists can go back and see the universe's freedom at work, and the various explanations going on. All the various galaxies and star systems within those that have been. All the various, the biologists will talk about all the various life forms and all the extinctions that have happened, just on our Earth, let alone, say, another planet somewhere else. All these explorations that have gone somewhere, but not a whole way, and other lines have been more fruitful. There's an enormous, Father George Coyne will talk about the patience of God, allowing this freedom to creation. And in a way, I find that a much more satisfactory, as it were, relationship that I can have with God than a God that says, do it this way, and do it this way, and do it this way, and do it this way. Okay, that dictates every step of the universe. I like a God that gives us freedom, the universe freedom. And with that freedom, of course, for us is always a responsibility. So, mind.
We believe, and faith teaches us, that human beings are the end product of evolution as we know it now. The Voyager spacecraft, there have been 2 of them, took off from Earth 35 years ago, and they're still going. And when they turn their cameras back, as we could see from Hubble, and look at Earth, we are at best a speck in the universe. How do you put together those 2 perspectives of, and make some statement about what is the significance of human life and Earth in the big picture of things?
It certainly is awesome. And I have a friend who is a biologist, a cellular biologist. She understands, cells extraordinarily well and their interaction. And her sort of reaction to the night sky when you're way out of town and things are really dark and the stars almost seem to reach down to you, it was one of awe, yes, and really of fear as well. And part of that fear, there's a fear that we are the only intelligent civilization in the universe, and there's also a fear if we're not as well. So it sort of works both ways. And sometimes, we can all resonate with that fear. But I hope that, through faith in God, that fear can be transformed, as it were, back into an awe and back into a wonder of what we are, sentient creatures, so creatures with intelligence, with emotion, that are able to make sense of this universe and be related to the Creator. And it's this related to the Creator that, as it were, removes the fear and even removes the awe of, if the whole universe has all kinds of other life forms in it, because it's all under a God who has created it, not because God had to create it, but because God loved so much that God simply has to create.
I'm going to ask you an introspective question. I can ask it, you don't have to respond to it. You understand the perspective of faith and the perspective of space. And how much of your time do you spend with that feeling of fear versus how much of your time do you find yourself overwhelmed with awe? Do you experience both?
Much less of the fear, much more of the awe, I think would be the answer to that. And my own...
But the fear part, we're not in control. Look at all these forces that decide where the Earth is and where it's going and what the weather conditions are going to be, and something might hit us and all those kinds of things. Those are real, aren't they?
They are real, yes. And disasters, happen. There's obviously things we call natural evil, the things of the earth, earthquakes, and as you say, hurricanes, all the rest. And yet one realizes that what we're dealing with is matter. And if it's matter, then it's never ideal. First of all, in order that there should be evolutions, things die. Species go extinct. So this is part of the pattern of which is both, wondrous and yet also gives one pause. That this is what we're involved with. The natural things, earthquakes are because of the movement of the Earth's crust, as you know well. Without that movement, there wouldn't have been the conditions for life to happen on our Earth. So sorry, you can't have it both ways. We'd love to, but that's the constraint of matter. And that's obviously what scientists try and understand, the constraints that matter put on it. Hurricanes are redistribution of the energy that the sun pours onto the equator regions of the Earth, and that energy has to get redistributed more through the Earth, around to the poles. And hurricanes, are a part of that redistribution. There's no other way in physics to do that. So again, we have to accept the world in its less than ideal manner if we are to accept a world that has life. You can live on the moon, and that doesn't have hurricanes, I assure you. But it's not such a great base, at least to try to start to live. You have to take all your own supplies with you. Whereas, our Earth at least has the basic supplies that we need for life. Yeah. Constraints of matter.
I encourage you to write questions, and I know the folks in the back have some, so they'll bring them forward, and I begin to ask yours. I'll ask you one other. Your own study is the study of stars.
Yes.
What is it that you find yourself looking for, and what is it that is challenging and fascinating for you about the study of stars?
I suppose all kinds of things. I'm in some ways a generalist with stars. My initial technique to look at stars is something called classification of their spectra. And if you're wondering what spectra are, if you'd seen a rainbow, then that's the spectrum of the sun. But in a rainbow, you don't see very much fine detail in it, so you have to put it through what's called a spectrograph to see very fine detail. And what's interesting is not so much where the light is present as where the light is not present. So where there's dark, when you can see the spectrum of the sun in detail, it's those dark bits that actually are the fingerprint of that particular star, is what makes that star unique, with its composition of elements and its temperature and its pressure and its conditions, and from that you can find all kinds of things. So I'm a sort of a generalist of stars, from the very hot to the cool. But I got into a survey of neighborhood stars, the ones you can find just by reaching out your hand, a mere something like 120 light years radius around our sun. And what you find there are an abundance of stars that are pretty much like the sun, and with colleagues have picked out some 30 that are very much like the sun, except that they're much younger. They're about the age that our sun was when life was starting on the Earth. Our question is, what was our sun like? How tough was it for life to get started on Earth at that time? Was there intense radiation, storms, solar storms on the sun that made radiation on Earth and made life pretty impossible or difficult? Or perhaps this radiation even helped the development of variations in the biology, and so life to happen. What was our sun like? So we're hoping by studying these stars to get a better idea of a young sun. So that's one angle we can go.
Some great questions here. So if we could have infinite lives and could travel to the edge of the galaxies, what would happen? Would we fall off?
No. To the edge of the galaxies, that's an interesting one. I tend to say, rather like the edge of our solar system, like the voyagers, would just keep going. But be sure and keep a good notebook when you do so, and let me know, because at the edge of the galaxies we have this stuff called dark matter. And there is matter out there around within our galaxies, and particularly at the edge, that we simply cannot see. Other matter we can see. It gives out radiation of one kind or another, and that's why we can detect it, be it with our telescopes or our radio telescopes. You've got a big one nearby at Green Bank. So with all kinds of detectors, we can, as it were, see. I know you've got radio eyes. So if you had radio eyes, you could see these things that the radio telescopes do. But there's a lot of matter out in our edges of our galaxy, our own galaxy, that we can't see, and the edges of other galaxies. And as I hinted I think I said at the beginning, when we don't know what something is, we call it dark, so this is dark matter. We don't know what dark matter is. Please take good notes.
Father Corbally told me earlier that that's on the top of his list of things he wants to know. So when you make that trip, he's serious about wanting the good notes. If we are not alone in the universe, did Jesus visit any other planets? And if not, why not?
The answer is easy. I don't know. And so... if you asked me if I wanted to meet an extraterrestrial, intelligent, obviously extraterrestrial, the answer is sure, I'd love to.
That's the next question. Is there such a thing?
Well, I'd like to know, we'll get on to that. Use your imagination at the moment. What if? Yeah, what is their experience of God? What is their religion? I think that, there is, as it were, an innate capacity in humans as part of other capacities that we have that is a religious one. So you can obviously look at the religious, your own religious nature, with the eyes of faith, and that's very, obviously you've got to do that, and as it were, with the eyes of science as well. To look at it as a phenomena and see how did it develop in the history, the biological history of our own planet, leading up through the apes to the hominids and to the humans. There is, as it were, a data that. What was that data like for E.T., for instance? So what is E.T.'s experience of God? That would be a fascinating thing. People have conjectured, about, the Savior on other planets. I think I have to simply wait and see. I don't restrict God to being able to save just us. That would be arrogance. If there are other intelligences out in the universe, that would surely be arrogance. I think it would be arrogance to say they would have to wait till we told them about the God become incarnate, on our earth. Because I think that limits God's imagination, as it were, God's ability to reveal God's self to every intelligent creature, and to save and make part of God's kingdom every intelligent creature. So, beware of arrogance when you do that, and let God be God, which is way more than anything we can ever imagine. And that's always the wonderful thing. If a scientist has a wonderful time exploring the universe, just think of the person of faith exploring the wonders of God.
The E.T. question, is it possible that there is something like human life in other galaxies?
Again, it's something we don't know for sure, but science at the moment is kind of putting things together and saying that the conditions seem to be there. We are finding planets around other stars. We are now finding, thanks to Kepler, the satellite that's up there staring at just one patch in the sky, second by second. boring, but not for us, not when you're looking for planets around the stars in that patch of sky, that there are indeed planets getting more and more Earth-like and of such a distance from their own sun that the conditions are favorable for water being liquid on the surface, and that is what makes life possible on our own Earth. So yeah, the conditions seem to be growing out there. Whether they are, how do we cross the divide between atoms and molecules and life? I don't know, and people don't know the answer at the moment. But that it has a possibility of being crossed, sure. We don't see anything at the moment against it. Okay, so it's a kind of a negative scientific evidence, and there may be. We may suddenly come up against a block, but so far so good.
Is the universe's expansion slowing down, and will it at some point begin to contract?
Unfortunately, no. Or fortunately, depending on whether you, how you feel you want to end in a big crunch. Things will get pretty hot in the end there. The current evidence that the universe, far from slowing down, is accelerating in its expansion and has been doing so for the last third of its lifetime. That's what seems to be, the evidence from looking at very distant galaxies and the rate at which they are receding away from us is to a universe that's been accelerating for a good while. Again, I'm sort of hesitant of that because this is science. If we come back in 10 years' time and suddenly find the picture has changed, I wouldn't be that surprised. But that's the evidence at the moment, that in fact, no big crunch, but rather an increasing expansion. I think probably no big crunch from what we know of the current, the density of the universe. Things have to be dense enough for the expansion to be slowed down, and so a contraction to happen in the far distant future. As far as we can see, the universe is not that dense as what we see. I hope you counted all those galaxies on the screen and came to that conclusion yourself, okay? But that's the kind of thing people know.
Your explanations about the relationship between God and science are probably not persuasive to the 46%, and millions were raised to build a creationist museum in Cincinnati, Ohio. Have you ever changed the mind of a creationist?
I don't think I ever have changed the mind of a creationist. I certainly wasn't conscious. I may have done by speaking and they happened to be changed, but nobody's ever come to me and said, oh, I was completely changed by that.
Faith lives eternally.
Yeah,
right?
it sort of is deep ingrained. So faith is something like that we catch and get from others, and it's very strong. And so to simply give people, say, the scientific evidence, I find that people will compartmentalize. They'll say, oh yes, that's very good, and they'll pass their astronomy exams wonderfully, but then ask them about whether they believe in evolution, and their faith says no, they don't. So there's kind of there's a wall, and I really don't know the way to sort of go through that wall, except to say it's not needed. I feel an idea of God that includes evolution is so much more of a God than the creationists that bang, with a snap of the fingers, everything is as we have it today. Oh dear. I almost find that disappointing, that the story of evolution is such a wonderful one, and that God should be behind this wonderful story, I find much more convincing.
Some of us look up when we pray. Why? Is God up there?
Sure. Well, we're awfully spatial, aren't we? And so, let's look up. If that's helpful, let's look up. In reality, God is everywhere, so we could look down as well. And like the Indians, we can both look up and look down, and we can look east, south, west, and north, all the directions. In all these directions, we find God. And most of all, we find God when we look in.
Please discuss the recent news about finding the God particle, the Higgs boson particle.
Yeah, it's a God particle, so it's good publicity. It, you know, it makes people read and buy books, and you know, like Big Bang, it's catchy, but God particle, yeah, not really. But fascinating, you know, for physics, because we're coming to an understanding of how things have mass. And that's a great breakthrough. The only thing that filled me with a little concern was that, in a report maybe a week or so ago, that the particle was exactly at the energy that they expected. And so if that's true, then are there other questions? Well, I think there are. You know, I think we'll find as we refine things in our measurements and our understanding that there are inevitably other questions. But for the moment, no, it's a great discovery. It's good to know where your weight comes from, after all, even if it might be a problem.
So much of theology comes out of our experience. Experience is one kind of revelation. How is theology expanding as our understanding and experience of the universe expands?
I think one of the ways that theology is expanding is this idea that you brought up with Guy Consolmagno, to realize that God is not an explanation for things in the universe that we don't understand. So to get away from that God of the gaps, filling in the gaps kind of idea. I was indicating a little bit through the, you know, that idea that Father George Coyne was picking up on God's allowing the universe freedom to develop and to explore, that's certainly something that theologians should be taking into consideration of what they say, our understanding of God. So that's another way. There's obviously also our understanding of the environment and the interconnectedness of everything that's around us, and the interdependence that's there for the survival of everything, including ourselves. So what we call ecology. That that understanding of God's relationship within to the interconnectedness that everything that happens. Yeah, that's I think a fruitful area, as it is for people who are involved in, as it were, the theology of ecology. Yeah.
Your thoughts on the new Pope?
Surprise.
Jesuit getting elected to be Pope?
We don't, things that don't happen. Jesuits get suppressed, they don't get, Jesuits don't get elected Pope.
It'll never happen, right?
So it'll never happen. Yeah. Wonderful. And I was just reading this afternoon a letter exchanged between the Jesuit general, some people call the Black Pope, and Pope Francis, or the White Pope. They were beautiful letters, and they first of all had a phone conversation the day after that Pope Francis was elected, and then quite shortly after that, our Jesuit general went to visit the Pope, and there's a beautiful picture of them sort of greeting each other and a wonderful smile on the Pope's face. It's good. We should also, I know as Jesuits, expect challenges from this Pope, and that is good. Any organization needs to be challenged and not to feel complacent. Oh, good, we got a Pope, that's it. No, he should challenge us, and that will be good.
If God created everything, what created God? Isn't it a cop-out if one were to say that God just always has been? Is it okay not to have faith? Is God man-made?
I think the question has almost answered itself. God is that which is not created. It's, whatever we call it, whatever we sense with it, it's always the ultimate explanation of why things are, and the explanation of why things are has to be something that in itself, himself, herself, however you imagine God, is not in itself created. So it's there. What you call it, that's up to you and your own understanding. But for me, that's God.
If you believe in God's providence, how does that fit in with the workings of the universe?
I believe in God's love of each individual. And with that, I also know that people die in hurricanes and in earthquakes. I'm not quite sure whether this is answering the question, but the questioner has in mind. But I think we have to hold both, that in a sense that God's not a magician who can make the physical world different than it has to be in order for there to be life, a bit that I explained earlier. So God's not a magician, providence in that sense that can preserve us from all harm. No, we are going to have harm, but God is going to be with us in that harm. God is going to be with the survivors of a hurricane or whatever. I was reading a bit about a survivor of the tsunami in the Far East, and she was the only one left in her family. God is with her, tough as it is to accept that that's what our world is like. So, yeah, the providence of God is that God is with us even through these things.
How does the information we obtain using a radio telescope, such as the one at Green Bank, compare with the information we get from an optical telescope?
Great question in science, and the answer is that all, radio and optical are all part of what we call the electromagnetic spectrum. So the electromagnetic energy. Radio waves are, sort of low energy. So they tell us different things than the higher energy in the infrared and the optical and, say, the X-ray will tell us. But altogether, they sort of pool the information. So I'm sort of helping with a workshop at the Vatican Observatory back at Castel Gandolfo in mid-May. And we're trying to understand a specific small area in Cygnus in which stars are being formed. And we want the information from all these different parts of the electromagnetic spectrum, from the radio, which is able to probe through and tell us certain things about the new stars that are being born there, as well as infrared and optical and all through. We need to pool all the information to make the whole picture, to see if our mathematical and physical models agree with the observations that we're getting. Because if they agree with the optical and not with the radio, it's not going to be right. So, yeah, all are important. Yay for Green Bank.
Keep the federal money coming, folks in West Virginia would say. There are several questions wanting to know the relationship between the observatory in Tucson and the Vatican observatories and other observatories in the scientific community, any relationship with NASA, federal grants, and all of that.
Just briefly, amount of history. The Vatican Observatory, while kind of putting its origins back to the reform of the calendar under Pope Gregory, so that's back in the late 16th century, puts its current form to late 19th century Pope Leo XIII re-establishing the observatory in the Vatican City, so it's sort of kind of behind St. Peter's. Light pollution in Rome was starting in the early 20th century. So in mid-1930 or so, the observatory moved out to Castel Gandolfo to get away from the lights of Rome. Once again, the lights of people living around Castel Gandolfo and commuting into Rome grew up. So in 1981, right at the beginning, we kept our headquarters at Castel Gandolfo and established a research base hosted by the University of Arizona. So we have now the two locations. What it does, obviously, is enables collaborations locally, and particularly I've collaborated with the engineers and that sort of side of the University of Arizona, what I'll refer to as Steward Observatory, which is the university's astronomy department. Much collaborated with them, that side of things, in building our new telescope, which you saw in the video at the beginning and maybe we're dancing to. So that's one aspect of collaboration on technical side. On, with astronomers, yes, the Vatican is a very small, but nonetheless quite a prominent member of the International Astronomical Union. So in the summer, I just handed over being 3 years as, Poobah of Stars. No, okay. The real title was President of Division 4 of the International Astronomical Union, and Division 4 was concerned with stars. So I was elected to look after concerns with stars for 3 years. So we do get involved internationally with groups. We have collaborators, all throughout the world as well. Yeah. Grants, yeah, well, actually we are looking for money. So if anyone knows a good source, let us know for running our telescope. I do obviously participate in grants of colleagues, and on the grant applications who are elsewhere. With a group of colleagues have just put in actually 2 applications for time on Hubble Space Telescope, and we've got our fingers crossed. Okay, you'll do cross your fingers or pray or whichever, or all, please, that we get our time, because the Hubble Space Telescope can see things in the ultraviolet, and when it's gone, we lose that capacity, and so it's important. We feel it's important to get our observations done before the Hubble gives out. Solve a problem that's been rolling around since 1943. So that's a long-term problem. It may not give the whole solution, but I think it'd be really helpful. Yeah, collaborations all over. Yeah.
Do you think there will ever be a time when exploration will stop and that there will be nothing left to explore?
So lovely question. You may remember at the turn of the millennium, as we began 2000, there were people saying, well, now we know all about things in science, and it's just a question of tying things up and tidying things up, and so that's all that'll happen in the next millennium. Because, science, the nature of science seems to be that when you learn, find out something, then new questions arise. In your very finding out the answer, so it produces new questions. So you have enormous satisfaction of finding something out, and then it just poses new questions. A little bit with a peculiar star that I've been involved with. Well, actually, this one that's been a puzzle since '43. Myself and a colleague found a very young example of this peculiar star. For those who might want to know what it is, it's called Lambda Boötis type star, after a prototype up in the constellation of Boötis. We found a very young example of this, showing that the leading mechanism for explaining why its atmosphere was peculiar would not hold. It was simply too young for this effect to take place. Great result, except that it led to more questions. So what is happening? I think that's the nature of science. I really don't think we'll come to the end of it. And I'd love to pose to you, and maybe you'll tell me afterwards, so what happens in heaven to scientists? Will they know all the answers? Will heaven be that boring? Think about it.
Is there any chance that this planet will become extinct?
Oh yes, a great chance. You know,
We will not end on that comment.
Make sure of your insurance. The only thing is, you might have to wait another 5 billion years to collect. Okay. Yeah, our sun is going to. Its nature is when it's exhausted, burning hydrogen and helium in its core, then it'll actually hydrogen in its core. It'll expand. And envelop its outer part of its atmosphere will envelop our Earth, so things will become too hot.
You're a delight. It's been very informative. And just before, I'll give you the last word and ask you the last question, but before getting there, I just want to thank you for your manner and perspective, and it's been great to host you at Charleston. You talk about the sense of awe that comes from thinking about the universe and looking at what we have looked at. What is your hope about directing that sense of awe toward life on Earth and the care of this world as we know it? What would you like for us to learn and do with that sense of awe?
I think it's there in the view from whichever, the Hubble or even people on the moon looking back on the Earth, seeing that we are on a spaceship. It's a big one, but it's not an unlimited one. So it's one that we do need to care for, and we're getting dangerously close to things getting out of control. So yeah, we've each got a responsibility. We shouldn't be hopeless about it, but to realize that each of us needs to take to heart the care of our planet, and so the care of each other. And that's part of our faith, yeah.
But isn't that one of the scary things? Because we're talking about the percentages of individuals who are not persuaded by science. And we have information about things that we should be doing on this planet and aren't. And so are you hopeful that we're going to be able to deal with the issues that we have?
I think I have to be hopeful, otherwise I'd get into the nearest rocket that's going out and jump on it and see what happens then. I think we have to be hopeful. We have to be hopeful in ourselves, that yeah, we do have the resources. Gosh, there's resistance, enormous resistance, but let's be hopeful. I think Pope Francis will help us in that regard. Pope Benedict, yes, had that sense, and trying to make the Vatican more energy sufficient, but somehow he didn't have the charisma that would spread and convince people. I think Pope Francis might have more of that charisma that would help us get the message, and so do something about it.
Clearly it's not science or religion, it's science and religion. Father Corbally, thank you so much for being with us.
Thank you so much.
Thank you, sir.